Welcome to today's video on capacitors and capacitance. In this short video, we will explore what capacitors are, understand capacitance, and learn about their charging and discharging process using interactive 3D simulations. We will also discuss the presence of capacitors in both AC and DC circuits. So let's get started. What is a capacitor? Well, a capacitor is an electronic component that stores electrical energy in the form of an electric field. It consists of two conductive plates separated by an insulating material called a dielectric. The plates are typically made of metal, and the dielectric can be made of materials like ceramic, paper, or plastic. Capacitance is a fundamental property of a capacitor and represents its ability to store electric charge. It is denoted by the letter C and is measured in farads F. Visualize the capacitance of a capacitor by using these input tabs for the changing area of the plates as well as the distance between them. The dielectric medium can be selected here. The capacitance of a capacitor depends directly on the area of the plates and the dielectric medium used. It is inversely proportional to the distance between the plates. Now, let's discuss the charging and discharging process of a capacitor. When a voltage source, such as a battery, is connected to a capacitor in a circuit, the capacitor starts to charge. During the charging process, the electrons accumulate on one plate of the capacitor, creating a negative charge, while the other plate becomes positively charged. In this 3D interactive visualization of a capacitor in a DC circuit, when the capacitor is fully charged, it reaches its maximum voltage potential. At this point, the capacitor acts as an open circuit, blocking any further flow of current. The voltage across the capacitor remains constant and no additional charge can be stored. When the capacitor is fully charged, it behaves as if it has infinite resistance, preventing any current from passing through. This state is characterized by a stable voltage across the capacitor's plate. While the capacitor is fully charged, it still retains the stored electric energy in its electric field. On the other hand, when the power supply is disconnected, the capacitor begins to discharge. The stored charge flows back into the circuit, causing a temporary current until the capacitor is fully discharged, as visualized here with the glowing of the electric bulb. This charging and discharging cycle can occur repeatedly depending on the circuit configurations. Exponential current growth during the charging and discharging process in a capacitor can be visualized here in 3D graphics. It is important to note that if the charging source is disconnected or the circuit is open, the capacitor will retain its charge and voltage until discharged or connected to a load. Capacitors find applications in both AC and DC circuits. In DC circuits, capacitors are often used to smooth out voltage variations or to store energy. For example, in power supply circuits, capacitors help maintain a stable voltage output by filtering out fluctuations. In AC circuits, capacitors serve multiple purposes. They can act as energy storage devices, timing elements, or filters. Capacitors are often used in coupling capacitors to block DC components and allow AC signals to pass through. They also play a crucial role in AC motor start and run, enabling efficient motor operation. In summary, the interactive 3D visualization of a capacitor explains how this electronic component stores electric energy in the form of an electric field. Visit effectual.com and effectual.github.io to visualize what you learn. The visual learning is more effective way of understanding any physical concepts. The amount of information you can retain will increase exponentially with this choice method of learning and understanding. I hope this video has given you a better understanding of the capacitors and capacitance. If you have any further questions, feel free to ask in the comment section below. Thanks for watching.